Hey, today we're going to talk about graphing lines from their slope-intercept forms. Before I say anything else, though, I'd like to make a request. I know math is intimidating. I'm a math person whose brain isn't math-oriented, and it takes me a ton of time and effort to understand new concepts. And I often get discouraged with things when I lose track of why I enjoy math in the first place. And that is that I love the puzzle of it all, the game within the process, knowing what I have and where I need to go and experimenting, sometimes more than once, with the process until I can get to where I want to be. So my ask is this. Just for the next couple minutes, try to think of this as a game. Find the hidden objects, organize the blocks correctly, pick up on the little details, try to focus on the process instead of the end result. The only stakes here are your own understanding. So take your time, think, and try to let your mistakes be a sign of growth instead of failure. To start, this does require basic knowledge of algebra and an understanding of the Cartesian coordinate system. But don't worry if you're a bit rusty, because I'll review everything before we jump into our example. So let's talk about the Cartesian coordinate system. It's much simpler and hopefully more intuitive than it sounds. We have two axes, the x-axis and the y-axis. Today, we'll be working in positive number land, which looks like this, because I personally love these guys when I'm learning new things. In the scope of all real numbers, the axes look like this, and we are going to be here in this quadrant. When you plot a point on these axes, it's written like this, with an x value corresponding to the x-axis, and a y value corresponding to the y-axis. X is always first, and y is always second. Cool. So now let's look at our slope-intercept form, y equals mx plus b. M is the slope, which is how steep the line is. Are you walking up a ramp where m is small, or a cliff where m is big? The y-intercept, b, is where the line intersects the y-axis. One fun thing we can put in our toolbox for later is that we can turn this intercept into a coordinate pair super easily. If you think about our graph, right, a point on the y-axis can't move on the x-axis, so x has to be 0. This means that our coordinate pair for b is always 0, b. Hold on to that later as we move on to our example. So our prompt is to graph y equals 2x plus 1. Now to graph a line, we really want 2 points that we can connect to make a line. So let's look at how to do that. Step 1 is going to be identifying our slope and y-intercept, and then turning our intercept into our first point. So here we see that m equals 2, because 2 is right before the x in our equation, same as where m is in our original equation. We can also see that b equals 1. Now, if you take that earlier knowledge from 2 seconds ago, we know that our coordinate pair at b will always be 0, b, because you can't move on the x-axis and also be touching the y-axis. So our first point is 0, 1. Step 2 is to figure out our second point. There's a couple ways to go about this, so I'll go over how to do it with a graph and then how to do it with algebra. First, a quick refresher on slopes. If you have a line and you want to move between 2 points but can't move diagonally, you're going to have to go up on the y-axis and then over on the x-axis, like stairs. We call this a rise, the change in y, over our run, our change in x. So we write this as change in y over change in x, which is a fraction. Pretty neat, no? So you'll notice that 2 is not a fraction, but we can do a fun, sneaky little thing here and say that 2 is the same as 2 over 1, because anything over 1 is itself. And now we do have a rise over a run, change in y over our change in x. So this next part, getting our second point from our first point using the slope, we can do this on our graph or we can do this on our paper with algebra. I'm going to show you both. We'll do the graph part first, and then I will show you our algebra. So if we do this graphically, we're going to draw our axes and label our first point, 0, 1. And then from this point, we will rise 2 units from that point, and then run To the right, 1 unit. We plot where we've landed, and now if we label it, you'll see that it's the point 1, 3. If we do this algebraically, we're going to write down our first point, and then we're going to add our change in x to the x value of our point and our change in y to the y value. So in doing that, we get 0 plus 1, comma, 1 plus 2, which also equals the point we got earlier, 1, 3. Now, in step 3, all we have to do is connect the 2 points with a line. I've got my computer set up to make super straight lines, but as long as your line looks mostly straight, you should be good. We'll label our line y equals 2x plus 1, and we're done. We've solved the puzzle, met our goal, played a game, and we have a process now for when we encounter other problems like this in the future.